I won't falsely accuse Gervin of doing anything today on video. All right, here's our motivation problem for today. So yesterday we talked about my friend Ryan, who's a millwright, had to cut a bunch of conveyor belts, needed to make sure that they were the right length. This is a different scenario. So say we're like a bylaw inspector for a township or a city, and somebody has just built this wheelchair ramp up to their building or what have you, and we got to go make sure that this is up to code. So to be an accessible wheelchair ramp up to code, the max it should have is a 5-degree angle. Now, out in the wild, it's hard to get out a protractor and like accurately measure angles. So, but it is a lot easier to measure horizontal distances and vertical distances. So we've got these measurements. This wheelchair ramp spans 12 feet horizontally and goes up by 1.05 feet. Is this wheelchair ramp up to code? Let's find out. So I've kindly provided a whole bunch of structure, and then as we move through it today, we're going to remove the structure so that you guys can just do these on like hypothetically like blank paper. So if we think about yesterday versus this question here, in this question, we're not given an angle. Instead, we're given the opposite and the adjacent. So I'm just going to label them down in my table here. I've got the opposite side. It's 1.05 feet. The adjacent side is 12. It's adjacent because it's next to the angle. And the 1.05 is opposite the angle. And so if we're thinking about setting up an equation using tan, and tan is what we would use here because we have opposite and adjacent, we get the tan of theta is equal to 1.05 divided by 12. Unlike yesterday, this isn't a proportion that we can solve and like cross multiply and get theta. The theta is like attached to the tan. So how do we do it? Well, I've coached you guys here. First of all, let's get this into a decimal. When I'm doing these problems and I'm converting things to a decimal, I always keep 4 decimal places just to be super accurate. In this case, we don't even have to round. It's exactly 0.0875. When we are finding angles, and everybody did this last year, so this is a nice little review. We use what we call our inverse tangent button. So on your calculators, that will show up as tan with the superscript of -1. It will be your tan button, but you have to press shift or second or something like that. So for those of you guys using a display calculator, you would have inverse tan of 0.0875, and then it will spit out an answer. I will do it now, and then I will tour the room and make sure everybody is okay. So I did that, and I got pretty much 5 degrees. It looks like our wheelchair ramp is up to code. 5 degrees seems pretty good. I'm going to tour, and if you didn't get 5 or you're unsure, I will just flag me down. And I will make sure you use our calculator. All good? All good? All right. I am touring, offering help, and nobody is accepting help, so I will just assume. Okay. Okay. So you're going to use your second function, and then tan. You can see how it's inverse tan, and then you can put in the decimal, and it spits out the answer. Okay? Yes. Yep. Yeah, just like the front, right? If I give you this angle, you got to work with that angle, or you can just find the other angle, but it gives you the same answer. All right. I will assume we're all in good shape. Can I just give a quick talk to you guys with display calculators? You can actually cut out the middle band here. You can just do inverse tan, and if you're good with brackets on your calculator, of 1.05 divided by 12, and you can skip the step of having that 4 decimal and rounding. You can just do it directly. If you want to try that right now, it's going to give you the same answer. Your calculators have no problem doing that. If you're using a calculator with no display, you will have to do the division and then press second tan. But nobody talked to me, so I assume you've all figured it out. But that's it. If we are finding an angle, we don't use our cross multiplication. We just use our inverse buttons. In this case, it was inverse tan. Let's try another one, and then we can take questions and stuff. Oh, Ryan's back. Okay. Inspecting a conveyor belt to see if it's up to code. So, again, impractical in the wild to actually measure angles. So Ryan was able to measure the length of the belt and the horizontal distance it covers. And we're going to look for this angle to see if it's up to code. We used tan the last time. Can you guys have a quick thought about which ratio to use this time? I actually think I'll do my attendance, and I won't forget to unpause the video. But you guys decide which ratio is appropriate, and maybe even take this question all the way. All right, I'm back. So grade 10U would be like, okay, I'm going to label my sides. This is the longest side across our angle. This is the hypotenuse, 34 meters. 25 meters is next to my reference angle. This is the adjacent side. So that means I'll be using cosine. This is all stuff you could just do in your head. You don't have to write all this stuff down. But yeah, cosine is the one we should be using here. We don't care about the opposite. It's not involved in this problem. The adjacent is 25. Hypotenuse is 34. So we will use cosine. So like the last question, our cosine of our angle is adjacent 25 over hypotenuse 34. And the math is the exact same. This time, instead of tan inverse, we'll use cosine inverse. And I think I'm going to mostly switch gears to just actually saving the rounding and just keeping things exact and just doing the inverse cosine of 25 over 34 in brackets. But by all means, get the decimal. Just keep a lot of accuracy if you're doing the decimal. What do we get? 25 divided by 34. I got 42.7 degrees. 43 degrees is fine. I don't think I specified to round to a specific. Yeah. Did you guys get that as well? It's finding angles with SOHCAHTOA. We can all do it. You could argue it's even easier than finding sides because there's no choice about multiplying, dividing. It's just using your inverse button. Anything you guys want to chat about? That's 2 in the books. All right, let's continue then. Can you guys set these up with no structure for me? Choose an appropriate ratio. Note the angle you're finding. And then we'll have a conversation about what I would consider bare minimum. Because I know how many of you guys like to just do the bare minimum.
Morning, Mr. Smith.
Good morning. Hello.
Oh, would you be able to send Michaela down to student services?
Sure.
Thank you.
That's where I want to say what's so good about it.
She likes Bobby.
What's that?
She likes Bobby.
Oh, who is that? Who was that?
I have no idea.
I don't recognize it. Oh, it might be. Oh, we have somebody new down there.
She sounded very ecstatic with her talking.
Which trig ratio did you guys use for finding angle T? Did you use the cosine ratio again? Yes. Because with respect to angle T, we're given the adjacent side. So let's talk about bare minimum. You know what? We'll do bare minimum after this one. So some of you guys may still enjoy just writing the definition of cosine just to get your head in the game. And then you plug in what you know. In this case, we have adjacent is 1, hypotenuse is 2. It's possible that you enjoy doing the decimal value, which would be exactly 0.5. And then if we do the inverse cosine of 0.5, that gives us, it's either 30 or 60. I forget which one it is. It's 60. 60 degrees. I showed a bit of work there. Here is bare minimum work for B. So for B, we're finding angle V. The hypotenuse is always the hypotenuse across in the right angle. This time 3 is our opposite side, so we are using the sine ratio here. Here is the bare minimum. We are using the sine ratio. So the sine of V, I'm not going to write out the definition of sine. I'm just going to plug things in right away. Sine of V is opposite of hypotenuse. It's 3 over 10. Show me what you're putting in your calculator. That would be the inverse sine of 3 over 10 or 0.3. And then show me your answer. This is my bare minimum requirement. Bare minimum of showing some work. You have been warned. Now this one doesn't work out to a nice whole number. Inverse sine of 0.3 to 1 decimal place, about 17.4 degrees. Did I do that right? 17.4? Okay. All right. 4, what's that? Did I do something wrong? It's entirely possible. Oh, 17.4. It would round to 5. Thank you for pointing that out. If you're rounding to 1 decimal place, I would fail a grade 5 rounding test. It does round to 17.5. All right, 4 in the books. We're going to start releasing the responsibility to you guys and doing some different types of questions. So just like the warm-up, sometimes you guys have more information than you need. This triangle has all 3 sides, and you guys are asked to find the angle at A, labeled with theta there. Some people, I can legitimately understand why, get overwhelmed with the choice. It's not fixed here. Like if I didn't have the 25 millimeter side, I'd have adjacent hypotenuse. I'd have to use cosine. There wouldn't be a choice. But if you have all 3, you can use either one, but they all lead to the same answer. That is what I'm trying to convince you of here. Can you guys convince yourselves that we get the same angle using sine or cosine or tan? This exercise is just to establish that idea. We should get exactly the same thing. Math makes sense all the time. So using sine, I would do sine of theta, sine of A, doesn't matter, equals 25 over 54. I would show what I'm putting in my calculator. So, good question. Does it matter how many decimals? If I don't say, I don't really care. I want to see the process. If I was building like a hospital for orphaned children and puppies, then I probably want to keep as much accuracy as possible to have, make sure my building is sound and all my measurements are exact. You know what I mean? But for reviewing SOHCAHTOA, 1 decimal place is fine. I'll tell you if it really matters. We should get the exact same thing for each one of those, for 27.6. Do you guys get 27.3 for this one? All right, so what this is kind of simulating is, say you're solving a triangle, maybe you're given 2 of the sides and you're using Pythagorean theorem, and maybe the hypotenuse isn't exactly 54, maybe it's 54.1 or 53.9 or something. Then we are going to have a little bit of rounding error, but hopefully you guys are convinced it's more or less the same angle, right? Around 27.5. So we should get around 27.5 for, excuse me, this final one. What do we got? 25 over 48. About 27.5 degrees. All right, you guys convinced? We get more or less the same angle no matter which ratio you choose? You guys won't get bogged down by choice out in the wild when you guys are solving triangles? You probably still will. All right. But this is just the kind of guy I am. We're solving this triangle here, but I've actually given you some beautiful structure. So we are going to solve this triangle where we have 2 sides. We need all the angles and the third side. So for the third side, if you have 2 sides in the right triangle, you guys, in your math toolbox, you should just reach for the Pythagorean theorem tool. It's right there. It's been burned into your skulls, ideally. In terms of the angles, I've coached you guys to find angle R first. Of course, it wouldn't matter. You could find angle Q first. Once you have 2 angles, you don't need to use SOHCAHTOA anymore. You can just use the fact that the angles add to 180. So I've coached you guys. You guys go. You guys go. I'll just play catch up in a few minutes. I'll actually pause my recording too. What could go wrong? I'll never forget to unpause.
What?
Oh, no, I didn't do.
I got my angles. You can double check them at the on the board. Yeah. Yep. Uh, 36 and 121 is 157. The root of 157, whatever that is, 12 and a half or so. About 12.5. All right, we've solved a right angle triangle where the two sides were given. Everybody did this last year. You guys just get a nice bonus review period. Third side, choose the appropriate tool. Pythagorean theorem is pretty simple and tidy to use. We did need to use SOHCAHTOA to find one of the angles, but then, again, use the most efficient tool. For the third angle, you can just subtract from 180 if you have two. I'll pass around some practice while you guys do the last one. Very similar situation. You have a triangle with two sides. I'm going to let you guys decide what to start with first and finish it off. I will come along for the ride later, but I'm going to actually pause the video here and just let you guys work. I'll use the cosine of b. 20 over 25.6.
I would show
All right, everybody, give me a moment of your time, and I'll be finished talking at you for the rest of the period. You guys can practice, okay? Now, I used my found hypotenuse of 25.6 to find angle B. I had to round 25.6. So when I used that rounded value to find angle B, I got 38.6 when I solved for B. If you use tan, right away, tan of B is 16 over 20. You get 38.65 or 6, and that rounds to 38.7. You have to keep this in mind. If you and your friend go at a problem with different strategies, find different things first, and you introduce a bit of rounding, you will disagree possibly by a decimal place or two at the end. But you're both right. If we were super concerned with accuracy, I would keep like 10 decimal places here, just make sure everything was rounded properly. But that's why I have 38.6. Maybe you have 38.7. That's why I have 51.4. Maybe you have 51.3. But we're all okay. Again, if we're building a bridge, we'll keep all the accuracy. If we're in grade 11 math class, reviewing grade 10 stuff, 1 decimal place is fine. And depending on the strategy, you might end up teeny tiny, slightly different answers. Does that make sense? All right, so that you guys won't have to get any fist fights about I'm right, no, I'm right. No, everybody's right. We just use different strategies. Bit of rounding error, we might differ by a little bit. All right, so you guys have practice options. Things escalate quickly after today. For the 3 people, we're learning something new tomorrow. We're starting to think outside of just conventional triangles, angles beyond 0 and 90 in a triangle. 3M people, yeah, you're actually okay. You guys just get to do an assignment tomorrow based on this stuff.